Hello everyone, I'm going to give you a video demonstration of the data manipulation in Jamovi exercise. So I am in the assignment repository, and you want to go and fork this to your own account and then switch to that repository, and however you want to get the files on your computer you can, but an easy way is just to do code and download zip, and then extract the file and you have it open. So I have that already here, and you want to open up the answer sheet, which has the instructions of what you're going to do. So I already have that open here also, and you're going to start at the top and work your way down. There's some questions to answer about doing statistical analyses. These were covered in previous weeks, so you want to go look up the answers to those and have them here. And we're going to get down to question number 5. Open the week 3.rds dataset in Jamovi. So previously in Jamovi we have opened up CSV and Excel files and an SPSS file. We're going to open an R dataset file that works with those also. So we're going to go to the File menu, Open, Browse, and we're going to go to our current folder for our assignment and click on Week 3 RDS and open that up. And there it is. So what are the variables in the data set and the level of measurement for each one? Make sure the levels of measurement are correct in Jamovi. And I think we did this once last week, but we can check it real quick. So we see male and female with nominal, qual with nominal. Height is measured in centimeters, and that's already set for continuous. Weight is measured in kilograms, and that's already set for continuous. We have love of statistics 1, that is ordinal. We do see there's some order there, so I'm going to change that to ordinal, and same thing for the other ordinal variables. Okay, that looks good. We're going to do, we could do a visual inspection and scan through that, but it's quite a bit of data to look through. So let's just go get descriptive statistics and look at those to make sure that things are looking okay. So we'll do our categorical variables first. And we're going to get our frequency tables. We don't care about means and standard deviations for categorical variables. And we're going to go ahead and get our bar plots. And if we look at these, we can see that none of them have missing data, and we have counts of 96, and then we have our different levels on each of the variables and what our frequencies and percents are on those. And looking at our plots, they look pretty good. So now we're going to go get our descriptives for our continuous variables. We can go to Analysis, Exploration, and Descriptives, and this opens up a new section, and we can take height and drag it over, and weight and drag it over. And this time we do want our means and standard deviations. We can also look at skewness and kurtosis and a normality test. And we're going to get histograms and box plots. So if we look, we don't have any missing data. We can see means and standard deviations there on our table. Minimums and maximums. So this is where you kind of use your clinical judgment or your domain knowledge to decide, are these acceptable or not. The one that looks a little weird to me is our minimum of 9.2 kilograms. That's a pretty light weight. So there might be something to look at with that. Skewness and kurtosis. This is a way to kind of judge normality. We're going to look at this more later on, but I did want you to get a little bit used to clicking those options because we'll look at this more. And Shapiro-Wilks is a way to run a statistical test to see if something's normal. And if it's not significant, then it does not differ significantly from a normal distribution. And we see that neither of these is less than 0.05, so it has not reached a level of significance. So for normality assumption, we're probably pretty okay. The one that we should double check is that really low weight. So if we look at our weight variable, we see on our histogram we have something down there, and we also have an outlier. So this is one where I would go back and see, is this a data entry error? Did somebody make a mistake? Or if I knew how these data were collected, I would go try to verify, why is this so low? And then I have a decision to make of, should it stay in the analysis or not? And you really need to justify your decision of why you left it in or took it out. And just because it's an outlier does not mean it has to be taken out. But in this instance where I don't know any extra information, this is made up. I put this in there so you could have an example of something that was a little bit odd. I would probably actually remove that observation from the analysis because I don't know where it came from, and I don't have a good read on it, so it could be a mistake, and I'd probably analyze the data without that, and that's the justification I would give. But it does look a little sloppy if you can't say why it's different. So definitely, if in a real data collecting situation, you want to understand why something is working or not working, because you don't want to look unintelligent. Okay, so we looked at our variables, and we've looked at each of those things. We've checked with using descriptive statistics. We've noted our one outlier. Probably would take it out of this analysis, but we're just going to leave it how it is because we're going to go through and do some other data manipulation stuff without running any inferential statistics on that. So we're going to create the variables in Jamovi that we did last week in RStudio. So we're going to do BMI, and again the formula is weight over height, and last week we did an example in Jamovi. So I'm going to go ahead and go to our data and click on our weight variable, and I'm going to do compute, and we're going to name this BMI, and we're going to take weight divided by, and we're going to say height divided by 100, put those in parentheses so we can take that value and square it, and hopefully if I don't have a typo, this will give us our BMI, and there's our BMI values in there. So there's our computed variable of BMI. We want to recode our level 4, our love of stats 4 variable, and we're going to reverse code those. So again, we'll go back to Jamovi, and let's go by our love of stats 4 variable and do transform, and we're going to do a new transform, and we're going to say 6 minus our source variable, because that was a trick we learned for recoding when we have them sequentially numbered and in order, and we'll hit enter, and there's our love of stats 4 variable recoded. And okay, we're going to create a new variable in Jamovi to calculate a final score for the love of statistics scale for each participant called the loss scale, love of statistics scale total. So we're going to create a computed variable for this, data compute, name the variable loss total, and the formula is going to be sum, and we're going to have our 4 variables, but we're going to use that recode. And I wonder if we can copy and paste that. Anytime that you can avoid making a typo, that's always a good thing. So let's go to the end and let's go to compute, and we're going to call this one let's use that. And let's try it. Oh, so I let it pick that name. So we're going to just make sure that we give our new variable the exact same name, because I didn't follow my own instructions probably. Well, let's try. Okay, so probably a good reason not to have spaces in your variable names. I think that probably caused a problem there. So go ahead and change that name to lovestats4 underscore recode and use it like that in Jamovi. And we're going to do the same thing for fear of statistics scale. And we'll go into Jamovi and we'll do another compute and call that FOSS total. And that worked nicely. And okay, we're going to do love statistics mean. So we're going to call this one loss underscore mean. Let's copy that formula and go to Jamovi and do compute. We're probably going to be okay on this formula this time, and we are. And we'll do another compute and call it fear of statistics mean, and we'll go back and get our formula. And that computed very nicely. Okay, let's see what else we're supposed to do. Create a new variable in Jamovi to calculate the z-scores for loss total, called loss total z. So we're going to create a computed variable, and luckily they have a function in Jamovi called z. So let's go give it a try. looks good. And we're going to do the same thing with loss mean Z. Okay, that's good. And now we're going to need to do the same thing for the fear of statistics scales. We're going to get z-scores for the loss total and the FOS total and the FOS mean. So we're going to go back to compute. Okay, and we can see that the z-scores from our sums and our means are the same. Okay, so now that we've computed all these variables, let's go get some descriptive statistics. So we're going to go to Exploration Descriptives, and we want to look at several things. So we're going to get the categorical variables, and then we want to look at the continuous variables. So let's go do that. And we already have those variables done, and the continuous variables that we don't have are our new scores. So I'm just going to click in the continuous variables analysis that we already did, and I'm going to go add in our new continuous variables. Let's just drag those over, and we can see now that it was pretty easy to add these in, and we can see our loss total plots and our FOS total plots and our loss mean and our FOS mean, and then our z-scores for those. And you'll see our data table is updated with those additional things, so we can see that what these have. So you see these total scores. It's a little harder to interpret these because they're on a different scale as the original questions. But we can see when we look at the mean scores, these are probably a little bit more interpretable without having to go look and see, well, what's really the minimum and the maximum possible. And same thing with our z-scores. So the mean on these, you'll see that those are really small numbers. This is scientific notation, so e to the negative 17. They're right close to 0, meaning that the average is pretty close to the mean. And so interesting stuff to look at. See if I had you pull anything else on this. Okay, so something I wanted to show you in Jamovi is the fact that we haven't really talked about this in these videos, but Jamovi is built on R, it runs on R. So one nice thing about Jamovi is we can actually get the R code that they use to do a lot of these statistics. And we can get that by going to these 3 dots arranged in a column on the right hand side in the upper right corner of the window, and under results and checking on this box that says syntax mode. And then we can close that dialog box right there. And you'll see that when we look at this, we get the commands that we use to get our descriptive statistics. And that is our categorical variables, the descriptives, and you'll see it's getting a bar chart in there. And I just looked these up online. You can look to see how this, but it's nice that Jamovi can actually give us this in the output if we're trying to learn how to format things in R a little better, or some of the syntax in R. So, and here is the information for the descriptive. So as you can see, this is good for the output. It doesn't necessarily give us the R code for doing the data manipulation that we've done, because that really wasn't part of the output. It was some manipulation that we did otherwise. But these are great. So what I think we're going to do next is go run some of this code in RStudio. So we're going to open up this R Markdown file and open with RStudio. And this should look familiar at this point. I'm going to make this a little bit bigger. And we're going to run our packages like we did before and make sure that things are installed, and we know that they work because we should have done that already. And we're going to open up our data file again, our week 3 RDS, so we can run that section. And then we want to put a code block, and we want to run our descriptive statistics. So I put a couple code blocks in there for you, and let's go do our categorical variables. And let's see, let's go back to Jamovi. And so if you right click, you can pick copy on the syntax, and let's go paste that into RStudio and run that. So you'll see that it called the data just data, and we called ours data set. So you'll need to go make this match the name of our data set that we used in RStudio. So let's go try that. And here you can see we're getting the same outputs that we did in our Jamovi. And I suspect I added these other descriptive statistics into RStudio, or into Jamovi on the continuous variables, that it's going to give us an error in R. So let's go try it out, and then we will go fix it. And we're going to syntax and copy, and let's go into RStudio and paste that into our syntax or our code block there. And we already know that we need to change our data set name to data set, so we can fix that right here. And I suspect that when I did these before, I did not actually have these mean scores in there, so I think this is probably going to give us an error, but let's run it and see what happens. And it says variable loss total doesn't exist. So we could go take it out of the Jamovi analysis, but there really isn't too much reason to do that because we can just alter the text right here. So let's just keep in height and weight and get rid of all these extra variables that we put in. And try running it again. And you'll see that ran great. So we have our height and weight, and there's our plots for those. So Jamovi can be a nice little way to help us learn some R code a little bit better. And you know, it's an option. We're not going to do that much this semester, but I just wanted to show you that it is something that Jamovi does and that you can use. So I'll let you read through some of these notes on Jamovi, what I thought were some of the advantages and limitations of it. And so we're going to save our Jamovi OMV file. So let's go into Jamovi, and we're going to export our output. So let's go to File menu and Save As and Browse. And we can call that, I'm going to actually call that Jamovi data manipulation, just to be a little more explicit. I'm going to go ahead and right click in here and go analysis, go to all and export and browse, and we're in our folder, and we're going to say Jamovi data manipulation output, and hit save. So we have a PDF that's easy to see on our output. And let's see if I asked us to save our some questions for you to answer on the answer sheet. And we'll go ahead and knit this our markdown file to a markdown also. So we're going to go into RStudio and go to knit and knit to MD document. Let this run for a minute. Okay, and I'm pretty sure I saw that file come up, and you see there's our new, if I go to my folder, there's my new markdown document, there's my output and my OMV file. So those all look pretty good. And then I will go to GitHub and go to add file, upload files, and drag my new markdown document and my new PDF document and my new OMV file, and you guys will click on commit changes. I'm not going to because I don't want these final files in the repository. And that's a demonstration of that video. I hope that helps. If you have questions or get stuck, come to office hours or post on the discussion section. Have a good day.